everything and anything. So every organ is kind of sits in the extracellular matrix, and any cell structure in the body is kind of surrounded by matrix. It's a network that is structural and functional. It was, let's say, detected or described in science quite late, I think in the 70s or so. And it was actually the reason that made us understand a couple of things that before intellectually we could not explain, like things like why would acupuncture work or how would homeopathy work and things like that. It's built by proteins and complex sugars that form a network structure that surrounds everything. It's, of course, the connective tissue, and it connects as well tissue and metabolic system. So communication between cells, between nervous system and the metabolism takes place there. It has the kind of ability that it can kind of change its configuration. So it can be gel-like and it can be sol-like. Sol is like when you melt ice, water. There is a moment when it's not yet liquid and not ice anymore, right? This is the sol condition. Gel is clear. This is kind of more jelly and is more solid. This is, for example, something that is strongly affected if people are too acidic or too alkaline, which is rarely the case, that this extracellular matrix is simply a little bit too dense, right? And so what is important to see is that it's not so much the cell or the condition of the cell, but it's always the environment that surrounds the cell that actually determines how a cell would function, yes or no. I come to a different, this is just Alfred Tischinger was the one that detected it and described it for the first time. So I named his book in here. But I think what is more important for you is to understand this one. I don't know if you ever thought about the anatomy of a cell and the bloodstream. Actually, a capillary vessel never ends inside a cell, right? It just streams by. So it's, if you, I don't know if you can see that, this is a cell phone. Can you see that? Yeah. And if you charge your cell phone, you take the wire, this is the wrong wire, this is from my headphone, and you plug it in, electricity goes straight into the cell. This is not the situation on cells and vessels. Vessels actually always stream by. You can see the cable now above my cell phone, right? And then you have this distance in between. You have the distance where actually the content of the vessel, called blood, has to leave the bloodstream, has to pass the interstitial space, extracellular matrix, has to pass the cell wall of the whatever kind of cell, then brings in the content to the cell. It's metabolized, I don't know, for producing energy, ATP, whatsoever. Waste has to go back, transfer the space of the cell wall, transfer the interstitial space, has to turn back into blood, and is transported off. Of course, this is mini nanospaces. This is tiny structures. One could theoretically, with an electronic microscope, have a look on them. And actually one can do so. I never had the chance to, but I have seen pictures of it. And this is the space that actually is a sieve, and that this sieve kind of gets more and more packed, more and more compact. You can imagine if then this sieve is kind of full of stuff of whatsoever, the exchange between blood, cell, blood is at least diminished. Yeah, so metabolism as such, as an exchange process, would be inhibited, would not work smoothly. By the way, you see that there's axons, so nerve endings, there's kind of fibroblasts, there's cells of the